All right, so with us we have Elena Gleich, Head of R&D for Dimension, and Laura Gorostiza, Product Marketing Manager for BASF Forward AM. And I'm going to go to the backstage and let you take it away.
Hello, everyone. Thanks for introducing us, Stephanie. Just give me a second. I try to share my presentation. Okay. Maybe Stephanie, you can quickly jump back. Can I only share an online version of the presentation? No, or?
You should be able to, if you hover over that share button, you should be able to choose present document.
Yeah, I used the wrong share button. Sorry for this. Okay, so now here we go. Okay, perfect.
There we go.
Then I hand over to Laura. She will start with our presentation about how we make sure that flexible materials like TPU enable AM serial production.
Can you hear me? Yes, okay. I cannot hear anything, unfortunately. There is some technical issue, but I'm gonna try to go ahead this way because anything I try is not working. But thank you, Elena, for the brief introduction I'm assuming you just made. And thank you, TP, for having us here today, and everyone that is ready to hear our chat about ultra-thin TPU and how it enables industrialization if it's done with the right partners. Not as sexy as the previous presentation, but I think you will like it. So my name is Laura Berestivar, and I am the Product Marketing Manager for Powder Bed Fusion in BASF. BASF may be a familiar name for you guys because it is one of the biggest chemical company in the world. What you may not know is that BASF is also one of the biggest TPU sellers, granule sellers in the world, which is our star character from today. Therefore, having such a strong backbone as BASF is, make us have three main market advantages. The first one is obviously the competitive TPU raw material, where our ultra-thin TPU01 will come from. The second one obviously is going to be the strong operational logistic system, and the last one, the commercial setup. And all together, will allow us to be a reliable partner and a material supplier. But our additive manufacturing business is a bit younger. It was founded in 2017 and takes the strengths of BASF and translates them into one of the biggest 3D printing material portfolio and service solutions in the world. So as you can see, the challenges that we face today are not about having the right material, right? It's about scaling up this material. And this is not an issue that we have in BASF, but it's in the whole additive manufacturing business. Therefore, we not only need the right material, right? We need the right machine to print the material. We need the right post-processing machine to depowder the parts and the right finishings. And therefore, what we need are right partners. So that's why in BASF, we believe that the only way forward is together with our partners. It could be machine manufacturers, it could be service bureaus, it could be end customers, and of course, it needs to be post-processing companies like Dimension. So Elena, what can you tell me about you and Dimension?
Thanks, Laura, for kicking off this presentation. So also from my side, a warm welcome to our audience. I'm Alena, Head of R&D here at Dimension. For all those of you who have not had the pleasure yet to work with us, just a few words about Dimension and what we are doing. The company was founded in 2015, and we are the leader in post-processing for industrial polymer 3D printing. So today we are the only provider for a fully integrated end-to-end solution. Our workflow is fundamented vision reality. So every day, the entire team works so hard to enable the era of digital manufacturing, where 3D printed products become part of our everyday life. Thereby, it's crucial for us to achieve this goal by focusing on sustainable processes. From my point of view, it's so important to have a sustainability in mind in everything we do. And this is also one of the guidelines of my work as a head of R&D here at Dimension. So my team regularly develops new post-processing processes. But for me, it's not only important to have a visually appealing result, but to achieve this result in the right way. So it should be always production ready and sustainable. So I'm very happy to present today together with Laura our joint work, because I know that also these topics are super important for BASF Forward AM. So Laura, maybe you can give our audience a short intro about our favorite material, TPU.
Yes, Alena, let's talk our audience about our amazing TPU. But I think many of our audience members may not even know what TPU is. So let's do a step back and understand where our ultra thin TPU is coming from. So as said before, TPU is coming from BASF material, the legendary elastolam brand, a material with, I would say, decades and decades of expertise across every single industry and sector of the injection molding world. So TPU is like a rubber-like material that is able to maintain the hardness and the softness regardless of the temperature. So whenever you hear, I need a flexible material, anti-scratch, energy return, vibration damp, that's where you will think that TPU is a perfect material for that application. But besides coming from a very well-known raw material, what makes our TPU powder so special? Alena's favorite material. So I think one of the key things about our ultra-thin TPU-01 is that enables industrialization. And the way that this is happening is because it was developed with HP for the HP 5200, meaning we have developed a plug-and-play system for our customers to print with ease, with optimal processability, with too much headaches. Thanks to those close collaboration, we are able to deliver a material that has excellent mechanical properties that, as you will see later, will serve many, many applications and industries as well. But that's not the only reason. Many people decide to go for our ultra-thin TPU-01 because not only we offer the material, but we believe on offering full solutions. So we start from the ultra-thin lattice simulation design. So if you guys want to change a foam from a lattice design, we are able to support you on that and help you tailor the mechanical properties that you may need. But of course, through the wide options of post-processing that we are offering for TPU due to our close collaboration with post-processing companies like Dimension. But I think now the main question after I told you all of this information is, does the industry actually recognize all those great features of TPU? And as you will see in the next slide, the answer is yes. But pictures, I think, and stories show more than my words. So here, just some of the few examples of applications that we have developed this year. But I think some interesting ones. So there's a helmet in the first row, almost at the end. This was developed for the NFL, or companies such as General Motors, just below the helmet, have also worked with us in bridge production applications. So I think the answer is indeed yes. The industry recognizes the benefits of this material.
Okay, Laura, so it sounds like everything is kind of safe because you have so many impressive applications out there. But do you have an idea why still not all companies are using the full potential of TPU yet? I mean, it looks like a perfect thing, but I imagine there could be many, many more applications, right?
Yes. So indeed, Alina, even though as we see more and more people are using our ultra-thin TPU1 from HP, there are still some that are, I don't know if reluctant, I don't know what the right word is, but there is still some misinformation in the industry about this material. The things that I hear most, especially when I go to fairs, are two main things. The first one is, oh my gosh, TPU is horrible to the powder. And the second one is the touch and feel will never achieve the injection molding level. So I think for our audience, and Elena, maybe you as well at the beginning, will think, are these actual challenges or are these just myths of the market? Let's start with the depowdering part. So depowdering, if people don't know about powder diffusion, PDF technology, depowdering is a key part of any printed part that you want to print. So it's essential. There are two intrinsic characteristics of a flexible material like TPU, which are the softness of the material and the rebound of the part that are making the depowdering a bit more challenging if you compare it to a normal polyamide. But of course, these are two different materials, so it will not make any sense that these materials are depowdered the same way, right? Why are the softness and the rebound challenges? The softer the material is, there is a higher adhesion of the powder to the part, and therefore you are going to need a higher blasting pressure to the powder. And regarding the rebound, a high rebound part will require higher energy depowdering because part of the energy will be absorbed by the part, as you can imagine. So we do have two things that are intrinsic of the material that we cannot change, but obviously, especially if you compare them to a polyamide, but obviously these are not challenges because as I just told you, we recognize them and you just need to find the right machine and different settings to depowder this material, but that doesn't make it more difficult. So the reality is that during the past few years, we have developed extensive know-how on how to depowder our TPU. And nowadays, with partners like Dimension, this is not an issue at all, even though people may still think it is. But again, it's a myth. When it comes to the touch and feel, again, people may think that you can never, and this is not only with TPU, it's in general in powders, you can never achieve this finishing, right, of injection molding when you work with powders. And yet again, this is a myth, especially if you have a chemical smoothing done at the end of your process. This chemical smoothing will give the shiny, smooth look that injection molded parts will have. And we can see that these parts actually look like injection molded parts where companies, again, like General Motors, are using, I think, 60,000 parts in 30,000 cars as bridge production project. And nowadays you will see two cars, one with injection molded parts and one with additive manufacturing parts in the street, and you will not be able to see the difference. And trust me, I've seen them, so I can assure you that. So to the question that Alina was doing at the beginning, yes, some people are reluctant to this a bit, but these are the main two reasons. And as we see, these are just myths of the market. But Alina, our most recent solution for these two topics, having with Dimension, what can you tell us about the solutions that we have with you?
Okay, Laura, now you teased it already a little bit, but I'm happy to give you some more insights how we could solve these post-processing challenges within our joint work within the last years. So let's start with the depowdering. Laura said it already, the depowdering is so crucial for any application. And so it is also for ultra-thin TPU. It's the first step after printing, and you really need to do it in a good way to have perfect parts afterwards. And I also have to say that if we only would consider the most commonly used blasting material on the market, which are glass beads, this myth unfortunately cannot completely be dismissed. So what we did, we examined various materials for their depowdering capabilities to see which material works best. And today I want to show you a comparison between glass beads and our new blasting material, the so-called PolyShot PC4 beads, which is a polymeric blasting material. And as Laura also said in the beginning, mostly pictures say more than words. So please have a look at this comparison. Can you see the difference? So on the left side, we have the parts which were depowdered with glass beads. We still have a lot of powder on the surface, especially here within the letters, for example. And also the channels here inside are still full of powder. The same is true for the lattice also. You cannot see it here perfectly. And in addition, if we depowder with glass beads, and as Laura said, we need a lot of energy, we always have a problem that the blasting material might break into parts, resulting in glass haze. So glass haze is like small splitters of glass being drilled into the surface of the part, which sometimes makes the surface kind of shiny. But this is not what we want because the surface is destroyed like this. In comparison, if you have a look on the right side, you see perfectly depowdered ultra-thin TPU 1 parts. So there's no powder left on the surface. Also, the challenge within this challenging geometry are powder free. And the same also is true for sure for the lattice structure. Yeah, so I hope with this visual in comparison, you can already see that with the right blasting media, it's not a problem to depowder TPU01. In fact, you get really good depowdering results in the end. And I don't have a lot to add here, but I want to highlight in addition that this new blasting material also allows us to use it in our industrialized cleaning device with PowerShot C performance. And like this, you can not only depowder TPU in a very good way, but you can also achieve clean parts in a 3 times more efficient way, which is a big benefit if you think about industrialized production. So to wrap this up, I can tell you that depowdering TPU is a challenge, but with our collaboration here, we could show that with the PowerShot C performance and the PolyShot PC4 blasting beads, we can perfectly depowder ultra-thin TPU 01 in an industrialized way. And like this, plenty of new applications can benefit from this great material without accepting any disadvantages during depowdering. And I think this is a huge step to many, many more TPU applications out there. Before also Laura asked about the look and feel. And in fact, if you remember the images of the past slides, a depowdered part is great, but there are some applications out there which might require even more. Because sometimes for your end use application, you have some additional needs which can only be fulfilled with a smooth surface. And for this, we have developed our vapor fuse surfacing technology. With this technology, you can achieve surfaces which are injection molding like. Laura teased already that there are cars out there where you cannot differentiate between an injection molded and a 3D printed and smoothed part. So having this second post-processing technology, we can also for TPU achieve high quality surfaces. And this is so important to understand because usually for 3D printed parts, the most well-known surfacing technology is a mechanical process. And this for sure does not work for TPU because it's so flexible. So we really need a different process. And here the vapor-based vapor fuse surfacing technology helps a lot because a solvent vapor condenses on the surface of the part, and like this can slightly dissolve the outer areas, and the polymer chains can rearrange like this. And after removing the solvent again, we end up with way smoother surfaces, as you can see them here on the left. So this technology is perfect for flexible materials, and especially aesthetic parts suffer from the superior look and feel. And here I want to highlight one additional benefit of our technology, because it's not like you can only smooth the parts. No, we have the possibility to achieve different levels of smoothing. So depending on your application, you can either go for a light smoothing, as you can see it here on the left. So for example, if you only need a sealed surface, or you can go to the strong smoothing, which you can see here on the right, if you really want to have a final application which is super glossy. However, vapor fuse surfacing is way more than just tuning the aesthetics. Due to the smoothing effect, also the mechanical properties are improved. If you already work with TPU, especially with lattices having very thin struts, you might have struggled with those struts breaking too easily. And this is a thing which can be avoided if you use vapor fuse surfacing, because it significantly improves the elongation at break, as you can see here. If here's the raw part, and here we have, for example, a part which was smoothed with the strong smoothing level, and you see that the elongation at break increases. And this is a big benefit for many applications, especially if the part is mechanically stressed. So if you think about shoe soles, saddles, or industrial components, like for example this gripper here, then the improved mechanical properties help a lot to really get this application running and working for a long time. But mechanical properties are also not everything. Especially if you think about medical applications, you might in addition need washable surfaces to make sure that you achieve the cleaning level you need. And also here, TPU01 can work super good if you smoothed it after the printing. And we have an additional side effect that after the smoothing, the parts have a homogeneously black color. So another benefit is that you can straight away use the parts after smoothing because they already look very appealing. So to conclude here, I hope I could show you that vapor fuse surfacing enables many applications for 3D printed ultra-thin TPU, which could not be realized without the smoothing, because you might need certain surface properties or mechanical properties, or just the look and feel of the only depowdered part does not meet your expectations. But it's not only challenging injection molded parts now. The big benefit if you go for 3D printing of TPU in combination with the smoothing technology is that you can now use a variety of new shapes and thus achieve different properties which cannot be realized with injection molding parts. So having said all this, I hope that the myths about 3D printed TPU should be a thing of the past. Or what do you think, Laura?
Okay, yeah. So thank you, Lina. I hope everyone really understood the point that we are trying to make today. Understanding how HP, TPU, and TPU from BSF and Dimensions collaboration allows us to have this industrialization, this solution for industrialization that we were discussing at the beginning. And now I know that I think, as you said, Alina, that with the creative audience that we probably have right now, people probably are thinking of many ways to use this solution. But if you do want to know more about us and about how we work together, I can only recommend taking a look to the white paper. This is a QR code to download it. You will see the test, the results, and much more information about how BSF, Forward AM, and Dimension are working together. So, Alina, I think, yeah, this is for sure not the end of the journey, right? We have many projects coming up this following year. So for all of us, for all of you, be posted. And this project obviously do not have to be just between Dimension and BSF. It can be with any of the people in the audience right now. So if you have any questions about TPU TPU and depowdering and vapor smoothing, as we just mentioned, but just in general information about our products and solutions, please do not hesitate to contact us. And if you do have questions about the presentation today, please drop them in the chat and we will love to answer them. Thank you very much. And thank you again, TP, for offering us the opportunity to talk today, and Alina for all the help in the process.
Yeah, also from my side, a warm thank you for listening. And I think Laura and I are happy to answer some of your questions. And if you still have time, we will also join the panel discussion afterwards.
Wonderful. Thank you, Laura and Elena. We do have a couple of questions. One that I saw in the chat just now is about the PolyShot material. They're asking if it's a 3D printed material, and I think it's not, right? It's just like it's a polymer.
Sorry.
Can you hear me?
Can hear you, but the PolyShot, you said?
Yeah, I think that's what they're asking about.
Okay, so PolyShot surfacing is our second surfacing technology next to vapor fuse surfacing. But as I also tried to explain during the presentation, the problem with the flexible materials like TPU is that they are so flexible and they have such a high rebound that mechanical surfacing technologies work not as good as we know it from rigid materials like nylons, for example. So if you work with TPU, I would highly recommend you to go for the chemical smoothing instead of the mechanical PolyShot surfacing.
All right, and again, the Q&A tab is open if you have any additional questions. There's one more that I see. So everything that we saw was parts made through multi-jet fusion. Is TPU available for other processes? And I think we just lost Laura, unfortunately. Oh, she's back.
But I think the problem is she cannot hear the questions. So I will answer here as well.
Okay.
So yes, so whatever we did here in this joint project was focusing on the MJF material. But in fact, there are many more TPUs out there, and also BASF is offering different TPUs, also some filament based, I think, and especially also TPU powder for SLS technology. So no matter which printing technology you're using, we can help you, I think.